Okay, so let's talk about merge two binary tree. So you are given two binary tree, root 1 and root 2. And this long paragraph is pretty long. I'm not going to read it, but look at this diagram. Like you have two tree, right? And you are given root 1 and root 2. So we just add 1 plus 2 equal to 3, right? 3 plus 1 equal to 4. 2 plus 3 equal to 5, right? 5 plus no is equal to 5. No plus 4 is equal to 4. And then the other one is no. And then the other one is no. So just leave it at no. And the other one is no. And this one is 7. So which will equal to 7. So just add. You add the other three node, and then you will get a new merge node. And this is how it is, right? So for this question, I'm going to use a depth first search. Depth first search is starting from the top, and then you will just traversing to the bottom, right? So how I will do it is I will say if root 1 is equal to no, I will say let's check about root 2, right? So this is how it is. And if root 2 is equal to no, I will say, okay, let's check about root 1. And this is the base case. Since we're using a recursion, so we have to know what should we return, right? So I'm not going to return any tree like root 1 or root 2, but I'm going to return a new tree, right? So I'm going to say merge tree will be something. And this will be the value. And also I will return the merge tree. And what is my value for the merge tree? It's going to be the value of root 1 plus the value of root 2. And what's on my left? So my left will be, I'm going to using this and root 1 dot left, root 2 dot left. And how about my right? So that would be exactly the same thing, but just right side. And at the end, I will just return a merge tree. The merge tree is the head, the root, right? This is how you are going to return, right? You are not return root 1 or root 2, but a new tree, right? So for this question, I'm going to describe depth first search, and the next video I'm going to talk about breadth first search. So before that, I'm going to talk about the time and space complexity. For this case, I'm going to say the worst case, the worst scenario for the time is maximum between root 1 or root 2. Because when you traverse a tree, right, you need to traverse to the end, the leaf of this tree, right? So it's going to be who is bigger than the other, then that would be the worst case for the time. And also the space, right? Because you need to generate another tree, and if you want to generate a new node based on the other tree, right? So you will get all of maximum between the root 1 and root 2. So they are, so time and space are all of maximum between root 1 and root 2. So for the base case, it's definitely going to be minimum, right? And that will be the solution. All right, so time for it, and let's talk about the breadth first search on the next video. But before that, if you like this video, press like and subscribe if you want, and I will see you next time. Bye.